Hello, everybody. So this is the video dealing with adding and subtracting radical expressions. In our weekly folder, this is under topic 7.4, and I've divided into two parts. This is part A. When we add and or subtract these radical expressions, the important thing to remember is that it's only possible if the radical expression has the same index and the same radicand, as you see here, for example. Okay, when we consider 4 radical 3 plus 7 radical 3, we have to look at the radical and the number inside it. And if they do match by index and radicand, we can perform the addition. Pretty much like if we had 4x plus 7x, we would get 11x. And in here, we would do the addition on 7 plus 4, and we would keep the radical 3. Okay? Same thing here, for example. When we look at this example, the very first thing that we see is that the value inside the radical, 12x, is not the same as 27x. So at first sight, these two are not what we call like radicals. So we would not be able to perform the addition. However, we are able to simplify both of these radicals into something similar. So in the case of 12x, we split it into radical 4 times radical 3x. In the case of 27, we split it as radical 9, radical 3x. We simplify radical 4 as 2. We simplify radical 9 as 3. We multiply minus 9 times 2. We multiply 7 times 3. And now look, after the simplification, both expressions have the exact same radical 3x, which means that we are able to perform the operation 21 minus 18, which gives you 3. And then we attach the radical 3x. Okay, so this is the basic case where the two radicals are easily identified as like radicals. We perform the operation on their coefficient. And in the case where apparently they are not the same, but it is possible through simplification that they become the same. And if that is possible, we perform the addition or subtraction, keeping the radical the same. Okay, good. Let's take a look at the examples we want to go over here. So let's go over example 19.18, which is the first case. Okay, so let's see. So this is minus 3 radical 5x. I'm going to copy it in here. So these will be all under either simplify or add subtract. Okay, and the reason that it might be under simplify is because we always want to simplify these things at the end to get the correct answer. Okay, so minus 3 radical 5 and a 5x and plus 10 minus 3 radical 5x plus 10 radical 5x. Okay, so let's make sure I copy this thing correctly. Okay, good. So this is an expression. It would be under simplify. And we have to check this value, the radicand, and the index, which in this case, there's an invisible 2. They match. The indices match, the radicands match, which means that I can perform the operation on their coefficients. So negative 3 plus 10, 7 radical 5x. We get to this point, this is the end of the operation. There's nothing I can do. Okay, just keep in mind that it may be possible that there's nothing that you can do sometimes. Let's say I have this problem. This is radical 5. This is radical 7. They cannot be simplified, which means I cannot perform the addition. So in this case, there's nothing that you can do, and you would just rewrite the expression. This will be the answer. Okay, so nothing to add in this case. In this, we were able. Okay, very good. Let's take a look at the second case, 1920. Okay, 1920 is a good case. 1919, take a look. These are all the same radicals with indices. I would add the 5 to the 4, which is 9, minus, there's an invisible 1 here, 8. So the answer would be 8 cubic of 7. This is a similar case to 918. So let's do 1920. 1920 is a very good case because, as you can see here, all of these radicands are different. So at first sight, there's nothing that we can do, but we may be able to simplify these two values. Okay, so let's see. So 2 radical 18. So 2 radical 18. 3 radical 32 plus 3 radical 32 minus 16 radical 2. Okay, again, at first, it's not possible to do the addition as is, but we can simplify. So I can write 18 as that. I can rewrite 32 as, maybe we'll just make sure that we write this a little bit better. And there's nothing I can simplify with radical 2 here. And notice the way I broke this, instead of, for example, 6 and 3, which is also 18, is because I cannot simplify this and I cannot simplify this. But the 9, we can simplify. Square root of 9 is 3. So this will be 2 times 3, radical 2. Same thing here. This is 3 times 4, radical 2. And here is our 16 radical 2. Now we multiply these two. Multiply these two. And here is my 16 radical 2. And look now that this radical is the same as that, is the same as this. So now we do the operation on the coefficients. 6 plus 12, 18, minus 16, 2 radical 2. So something that at first did not seem to be something that we could perform the addition, it turns out that after the simplification, we got the final answer as to radical 2. So this is what a typical problem looks like. It's a very good problem because it's very likely that you're going to get something like this on an exam or final exam. And let's see our last problem, 1921. Okay, so here is 1921. 5 cubic, 16 square. Five cubic, 16x square, minus 6 cubic, 54x square. (64x square), 54x square. Okay. They do not match. We have to make sure that we can do something so that they do match. So I am going to rewrite this as cubic 8 cubic 2x squared. Right? So 8 times 2 is 16. That's good. And I'm going to do the exact same thing here. 27 2x squared. All right. And the reason I broke it this way is because now I can simplify cubic of 8. That is 2. There's nothing I can do here. Same thing here. Cubic of 27 is 3. Nothing I can do there. Don't forget to put the index. Okay, and now they match. So 5 times 2. 6 times 3. Now that they match, we perform the operation on their coefficients. 10 minus 8. And this is my final answer. Okay, so this is again a typical case where they do not match at first, but after simplification, they did. And we were able to get our final answer. Okay, so these problems are typical addition and subtraction of radical expressions where we may have to simplify the radicands, or in the most basic cases, we don't have to. Okay, so in the next video, I am going to show you how to do multiplication of radical expressions.